Welcome, my dear students, in Prep 3. Today we will continue Unit 4 in Geometry. Our session today is about the relation between the chords of a circle and its center. If you have a circle M and you have two chords AB and CD, the distance between the center and the chords is MX and MY. Like here, we have AB and CD. There are two chords in this circle M. The distance from the center to the chord is MX and MY. We notice that if AB greater than CD, then the distance between the greater chord and the center is less than the distance from the smaller chord to the center. So if AB greater than DC, it means that MX is less than MY. By the same way, if AB is less than CD, in this case MX is greater than MY. And if AB equals to CD, and so the two chords are equidistant from the center. So the closer the chord is from the center of the circle, the longer its length is, and vice versa. So if we have two chords of a circle and the two chords are congruent, then they are equidistant from the center. We can prove this theorem. For example, if you have two chords AB and CD, they are equal in length, and the distance is MX, which is perpendicular to AB, and MY, which is perpendicular to CD. And we know that I want to prove that MX is equal to MY. So I will draw a line segment MA and a line segment MC, and we know the two line segments here are equal because they are two radii. We can easily prove that the triangle AXM and the triangle CYM are congruent because we have two right-angled triangles. The hypotenuse is equal because they are two radii, MA equals MC, and also MX perpendicular to AB, so AX equals half AB, and because this is a line segment passing through the center and perpendicular to a chord, so bisect the chord, and also MY bisect the chord CD. It means that AX equals half AB and CY equals half CD, but half AB equals half CD because they are equal chords. So the two triangles are congruent. From congruency, we will see that MX equals to MY. So MX equals MY. So if you have two chords which are equal in length, then they are equidistant from the center. In congruent circles, chords which are equal in length are equidistant from the center. By the same way, but in this case we have congruent circles like here. M and N are two congruent circles. If AB equals to DC, then NY equals to MX. By the same way. Here we have an exercise, and the opposite figure, AB and AC are two chords equal in length. So given that AB equals to AC in the circle M, AD is a diameter of this circle, MX perpendicular to AB and intersected at X, also MY perpendicular to AC and intersected at Y. Prove that BD equals DC. BD equals to DC. Okay. At first, we can notice that we have two triangles, ABD and ACD. Okay. MX is perpendicular to the chord AB, So x is the midpoint of AB. By the same way, M is the midpoint of the diameter AD, because this is a diameter, the center is the midpoint. Also, Y is the midpoint of AC because MY perpendicular. So, in the triangle ABD, X is the midpoint, M is the midpoint, X is the midpoint of AB, and M is the midpoint of AD. It means that MX equals half BD. This is the first notification. The second, here we have also a triangle ACD. M is the midpoint of AD and Y is the midpoint of AC. So MY also equals half DC. But we know that AB equals to AC. The two chords are equal, so the two distance from the center are equal. So MX equals MY. It means that half BD is the same as half DC. It means BD and DC are congruent. Okay. So M is the midpoint of AD because this is a diameter and M is the center. ABD, we have in triangle ABD, MX equals half BD because X is the midpoint of AB and M is the midpoint of AD. Also in triangle ACD, MY equals half DC. Why? Because Y is the midpoint of AC and M is the midpoint of AD. But we know that MY equals MX. MY equals MXY because AB equals AC. The two chords are equal, so the two distance from the center are equal. So half BD equals half DC. Multiply both sides by 2. BD equals DC. Also, we have the converse of the theorem. In a circle or congruent circles, chords which are equidistant from the center are equal in length. So chords which are equidistant from the circle are equal in length. Like here, if the distance mx equals to ny, it means that AB equals to AC. By the same way in the second figure. Here we have another exercise, and the opposite figure ABCD is a triangle. Here we have ABC is a triangle drawn in a circle. So this is inscribed triangle drawn in the circumcircle M. AB equals AC. What does it mean? We have two chords are equal. AB equals to AC. X is the midpoint of AB and Y is the midpoint of AC. Measure of angle YXM is 20. I want measure of angle CYX. CYX. Okay, let's see. Okay. Here we have I want the measure of angle CYX. This is CYX, this angle. I want the measure of this angle. Okay. Since X and Y are the midpoint of the chords AB and the chord AC, it means that this angle is right angle. Okay, this angle here is a right angle. And also this angle is a right angle. This angle is 20. We know that AB and AC are two equal chords. It means that the distance are equal. So MX equals to MY. MX equals to MY. So this is an isosceles triangle. So if this angle is 20, then this small angle also is 20. And this angle will be 20 plus 90. So it will be 110. Exercise number 2. You should get the 110. This is the measure of angle XYC. Okay, or CYX. Another exercise in the opposite figure, AB and CD are two chords. AB and CD are two chords in the circle M. MF perpendicular to CD. This is MF and it's perpendicular to CD, and also ME is perpendicular to AB and intersected at Y and X. X is the midpoint of AB. Okay, since X is the midpoint of AB, so this angle also is a right angle. Prove that AB equals CD. Where is AB? This is AB and this is CD. Okay. If you want to prove that AB equals to CD, it means that I should prove that MX equals to MY. How can we prove that? Here we have ME and MF are two radii, so they are equal. Also XE equals to YF, so if we subtract XE from this radius and YF from this radius, we will get that MX equals to MY. Okay, so they are equidistant from the center, so the two chords are equal. Okay, ME equals to MF, XE equals to YF, it's given. I'll subtract, so MX equals MY. In this case, it means that the two chords are equal. Okay, that's all about our session today. Next session, we will begin studying Unit 5. Thank you very much for watching. See you next session and goodbye.